to True Projects. In this video, we are going to explain about a project titled Lung Cancer Prediction Using Machine Learning. Lung cancer is a pressing global health concern and early detection plays a pivotal role in improving the patient outcomes. In this project, we embark on a mission to harness the power of advanced machine learning algorithms to develop a highly accurate and efficient lung cancer prediction system. By analyzing the patient data and identifying the potential lung cancer case at an early stage, we aim to enhance the precision and the timely medication intervention. With the amalgamation of cutting-edge techniques, rigorous evaluation, and the ensemble methodologies, our ultimate goal is to create a robust model that empowers the healthcare professionals to detect the lung cancer promptly, thus saving the lives and elevating the healthcare standards. And the objective of this project is to build a robust lung cancer prediction system using the state-of-art machine learning algorithms. Our primary goal is to achieve the exceptional accuracy and precision in identifying the potential lung cancer cases from the patient data. By employing the advanced techniques like feature selection, hyperparameter tuning, and the ensemble methods, we aim to create a reliable model capable of early detection. This project strives to empower the healthcare professional with a powerful tool for the timely medical intervention, thereby improving the patient outcome. Additionally, we aspire to contribute to the ongoing effort in the fight against the lung cancer by leveraging the data-driven methodologies to enhance the accuracy, reduce the false negative, and ultimately save the lives. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. It begins by importing the essential Python libraries such as NumPy, Pandas, sklearn, and Matplotlib. These libraries offer the tool for data manipulation, visualization, and model building, vital for lung cancer prediction using the machine learning. And the second one is importing the dataset. Dataset is loaded typically in a CSV format using the pandas to create a data frame. The dataset contains the information about the patient, their attribute, and the cancer diagnosis. And the third one is checking for the null value. Examine the dataset for any missing value that might impact the model training. Handle the missing data through imputation or removal to ensure the data integrity. And the fourth one is checking for the correlation between the variables. Analyze the correlation between the features to understand their relationship and identify the multicollinearity issues that impact the model performance. And the next step is label encoding of the important variable. If the target variable is categorical, encoding is into the numerical value using the label encoding, enabling the machine learning model to process it efficiently. And the next step is feature selection of the important features to build the model. Identify the significant features that contribute to the most model's predictive power. Use the feature selection technique for this. And the next step is applying the algorithm. Here various algorithms are applied. The first one is logistic regression. It is a linear classifier used for the binary classification task. It calculates the probability of an instance belonging to a specific class using a logistic function. The model is trained by minimizing the log loss between the predicted probability and the actual class label. And the second one is KNN. It stands for K nearest neighbor, is a non-parametric classification algorithm that classifies an instance based on the K nearest neighbor in the training data. It measures the proximity between the data points using the distance metric like Euclidean distance and assigns the majority class among the K nearest neighbor as a predicted class. And the third one is SVM. It stands for Support Vector Mission. Is a powerful classifier for the binary classification task. It aims to find the optimal hyperplane that maximizes the margin between the data points of different classes. SVM can handle the linear and the non-linear separable data by using the different kernel functions. And the next one is decision tree. Decision tree is a tree-based classifier that recursively splits the data based on the features to create the decision nodes. Each node represents a feature and split the value, aiming to maximize the information gain. And the next one is naive-Bayes. Naive-Bayes is a probabilistic classifier based on the Bayes theorem. It assumes the independence among the features given the class label and calculate the probability of instance belonging to the class based on the product of individual feature probability. And the next one is random forest. It is an ensemble method that combines the multiple decision tree for the classification. It aggregates the prediction of individual trees to make the final decision, reducing overfitting and improving the accuracy. And the next one is AdaBoost. AdaBoost is an ensemble method that iteratively improves the model performance. It assigns the higher weight to misclassified instance to each iteration and combines the multiple weak learner to create a strong classifier. And the next one is stacking classifier. Stacking classifier is an ensemble technique that combines the prediction from the multiple Bayes classifier using the meta classifier. The Bayes classifier output serves as an input feature for the meta classifier, which makes the final prediction. And the last one is voting classifier. It is an ensemble technique that aggregates the prediction of multiple classifiers. It combines the predictions either by majority voting or by weighted voting to make the final decision, increasing overall accuracy and the robustness. And the next step is accuracy comparison graph. Here we create a visual representation of accuracy achieved by each model to compare the performance. And the next step is training the model. Train the selected algorithm on the pre-processed dataset using the respective training method. And the next one is user gives the input. Here we using the class as a web framework where the user can view the input data to predict the lung cancer. And the next step is the given input is pre-processed for prediction. Pre-process the user input using the same pre-processing step as of the training data. And the next step is train the model is used for the prediction. Utilize the pre-processed user input to predict whether the patient has the lung cancer or not using the trained model. And the last one is display the final outcome. Display the prediction outcome to the user indicating whether the patient is likely to have the lung cancer or not based on the machine learning model analysis. And the execution of the project, we need to open the code folder. And this is the code folder containing of various files within it. The template folder containing of the index and result HTML files within it, and the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And this is an IPYNB file named of lung cancer prediction is used to contain of combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And this is the data set that we used in this project, and this is a pickle file named model contain the information related to the algorithm, and it loaded into the project code during the runtime to utilize the trained model for the various tasks such as making the prediction on the new data or performing the specific operation. And the execution of the project, we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this, it will change the current directory to the code folder's path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check or the syntax errors and the logical issues, and then click on the enter button. After running the app.py file, the class framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. And then click on the paste this link and click on the enter button. Here it will redirect it to this page containing of the lung cancer prediction and some of input details that are need to be filled. And here I am entering the details of yellow fingers of 1, and the anxiety is of 1, and the peer pressure is of 1, and the chronic disease is of 1, and fatigue is of 1, allergy is of 1, wheezing is of 1, alcohol consuming is of 1, coughing is of 1, and swallowing difficulty is of 1, and chest pain is of 1. And then click on the submit button. Here it will detect it and redirect it to this page and giving the prediction of you don't have lung cancer. In this way we can predict it, and by pressing the back button and the refresh button, here we can enter the other details too. And here I am entering the details of yellow fingers 2, and the anxiety 1, peer pressure is of 2, and the chronic disease is of 2, and the fatigue is of 2, and the allergy is of 2, and the wheezing is of 1, and the alcohol is of 1, and the coughing is of 2, and the swallowing is of 2, and the chest pain is of 1. And then click on the predict button. Here it will predict it as of having the lung cancer. In this way we can predict whether the person is having the lung cancer or not. And in conclusion, our lung cancer prediction project using the machine learning has yielded the high promising result. The ensemble of classifiers, including the decision tree, random forest, and voting classifier, demonstrated the remarkable accuracy in identifying the potential lung cancer cases. Although the naive and the stacking classifier achieved slightly low accuracies, the overall performance of the model showcased the effectiveness in aiding the early cancer detection. This project success underscores the significance of leveraging the machine learning technique to enhance the healthcare outcome. By implementing these models in the clinical settings, we can empower the medical practitioners with a reliable tool to identify the lung cancer at an early stage, thus potentially saving the life and improving the patient care.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.